What if the dream of creating machines that think like humans, or even surpass them, began not with powerful computers or massive data centers, but with ancient myths, wartime code breaking, and a bold summer workshop where a handful of visionaries dared to ask, can we make machines intelligent? Imagine a world where the very idea of artificial intelligence was once dismissed as science fiction, only to become the force reshaping every aspect of our lives today. This is the extraordinary story behind one of the most ambitious and transformative ideas in human history. Welcome to Story Behind the Things, the channel where we uncover the fascinating stories behind different things. Today, we explore the story behind artificial intelligence, from its ancient roots to the revolution unfolding right now. The desire to create artificial beings has fascinated humanity for millennia. In Greek mythology, Hephaestus forged golden robots to serve the gods. Jewish folklore tells of the golem, a clay figure animated by mystical words. In the 13th century, the inventor Al-Jazari built programmable automata. By the 18th and 19th centuries, clever mechanical dolls and chess-playing machines like the Turk dazzled audiences, though often with hidden human operators. These were more illusion than intelligence, but they planted the seed of possibility. The real foundation, however, emerged in the 20th century amid war and rapid technological progress. During World War II, British mathematician Alan Turing played a pivotal role in breaking the German Enigma code. His work on computing machines and theoretical frameworks laid essential groundwork. In 1950, Turing published the landmark paper Computing Machinery and Intelligence, posing the famous question, can machines think? He proposed the imitation game, now known as the Turing test. If a machine could converse in a way indistinguishable from a human, could we call it intelligent? But the official birth of AI as a field came in the summer of 1956 at Dartmouth College in New Hampshire. A small group of brilliant minds, John McCarthy, Marvin Minsky, Nathaniel Rochester, and Claude Shannon, organized a workshop. In their proposal, they boldly stated that every aspect of learning or any other feature of intelligence can in principle be so precisely described that a machine can be made to simulate it. It was here that John McCarthy coined the term artificial intelligence. The participants were optimistic, believing major breakthroughs were just around the corner. The main story of AI is one of soaring ambition, crushing disappointments, and remarkable resilience. In the years following Dartmouth, early successes fueled excitement. Alan Newell and Herbert Simon created the logic theorist, often called the first AI program, which proved mathematical theorems. Arthur Samuel developed a checkers playing program that could learn from experience, an early demonstration of machine learning. Researchers explored symbolic AI, using logic and rules to mimic reasoning. Yet the challenges proved immense. Computers were slow and expensive. Real-world problems were far messier than chess or logic puzzles. By the 1970s, funding dried up as promises outpaced results. This period became known as the first AI winter. A second winter hit in the late 1980s and early 1990s after the hype around expert systems faded. Critics argued AI had hit fundamental limits. Many scientists moved on or rebranded their work to avoid the stigma. The turning point came from unexpected directions. In the 1980s and 1990s, researchers revived interest in neural networks and connectionist approaches inspired by the brain. Backpropagation allowed networks to learn from data more effectively. Then, in the 2000s and 2010s, three key ingredients converged: massive increases in computing power, especially GPUs, enormous amounts of digital data, and breakthroughs in deep learning algorithms. Pioneers like Geoffrey Hinton, Yann LeCun, and Yoshua Bengio, later called the godfathers of AI, drove the deep learning revolution. Dramatic moments followed. In 1997, IBM's Deep Blue defeated chess champion Garry Kasparov. In 2011, Watson won on Jeopardy! But the real shock came in 2016 when Google DeepMind's AlphaGo defeated world champion Lee Sedol at the ancient game of Go. A feat once thought decades away due to the game's immense complexity. Suddenly, AI wasn't just calculating, it was mastering intuition and creativity. The birth of modern AI as we experience it today emerged from this data-driven, learning-based paradigm rather than pure symbolic rules. The transformer architecture, introduced in a 2017 paper Attention is All You Need, enabled the large language models powering tools like ChatGPT. What began as a theoretical pursuit became a practical technology almost overnight. This evolution was revolutionary because it shifted AI from rigid programming to systems that learn and generalize. Initial reactions ranged from wild optimism to deep concern. Today, while narrow AI excels at specific tasks, the quest for artificial general intelligence (AGI) machines that match or exceed human versatility continues with ongoing debates about timelines and risks. The impact on the world has been profound and is still accelerating. AI now assists in medical diagnoses, scientific discovery, autonomous vehicles, personalized education, creative arts, and countless daily conveniences. It drives economic growth but also raises urgent questions about jobs, privacy, bias, security, and existential risks. From optimizing supply chains to accelerating drug discovery, AI is reshaping human civilization in ways its early pioneers could scarcely have imagined. Here are some fascinating lesser-known facts that most people don't know about the story behind AI. First, the very first chatbot, ELIZA, was created in 1966 by Joseph Weizenbaum. It simulated a Rogerian therapist by turning users' statements into questions, and many people became emotionally attached to it, revealing early glimpses of how humans project intelligence onto machines. Second, early neural networks in the 1950s and 60s often had to be wired by hand. Researchers literally plugged in connections manually, making experimentation tedious and error-prone. Third, the term robot comes from the 1920 Czech play Rossum's Universal Robots by Karel Čapek, where it referred to artificial workers long before electronic computers existed. Fourth, during the AI winters, some researchers persisted in secrecy or under different names to continue their work without losing funding or credibility. And fifth, one of the Dartmouth proposal's optimistic predictions was that significant advances could be made within a generation. While it took longer than expected, the eventual explosion of progress validated their core vision in ways they couldn't have fully foreseen. As we stand at the threshold of even more powerful AI systems, the story behind artificial intelligence reminds us that this technology is not inevitable or purely technical. It is the product of human curiosity, perseverance through setbacks, visionary dreams, and careful choices. It reflects our deepest hopes and fears about what it means to be intelligent, creative, and human. The journey from ancient myths to generative models shows that creating intelligence outside ourselves is one of humanity's grandest adventures. Whether it leads to unprecedented prosperity, new ethical challenges, or unexpected wonders. The story is still being written, and each of us has a role in how it unfolds. If you enjoyed this journey into the story behind this idea, don't forget to subscribe to Story Behind the Things for more fascinating stories. Thanks for watching, and we'll see you in the next story.